Hello and welcome to the third lecture of Introduction to R, the content. We had already discussed about R programming, how to install it in our devices, and what are the basics commands for normal summary calculations and plots. We had done the introduction about the plotting in R and different types of plots in the last video. Today we're going to continue about how the different types of plot categories and the various customizations we can do in RStudio to get the desired output in a different types of aesthetic manners. So before starting, let me share my screen. So this is the RStudio window containing all the script console, global environment, and the plot window that we're going to get our visual outputs here. Now doing a slight recap from our previous video, we're starting with loading the base packages. This is where our base package gets activated. Next, we were loading the iris dataset that we had previously workshop on the last two videos. Here is the iris dataset. If you wanted to see, this is the particular data, 150 different observations of 5 different variables, where one of the variable contains categorical data, and all of the 4 remaining variables contains numerical or quantitative data. So we were previously plotting this particular dataset in different scenarios. For example, when we were plotting the entire dataset together, we were simply using this command. We were going to get a scatter plot. Then we wanted to plot only one of the specific variables of the iris dataset. So we were mentioning the dataset and giving a assignment operator to select different variables. So if I wanted to plot a numerical variable, we would get a plot like this. This is what the RStudio decides the plot would look like, given it is a numerical data. Next, if we wanted to plot a categorical variable, that is species, and if you wanted to plot it, we would be getting a generic XY plot where only the different types of variables present in species were given according to their frequencies. So this much we already covered in our last video. So today we're going to learn about the various ways in which we can customize our plots or graphs in RStudio. So let us start with the basic customization. Before that, what if we wanted to know about the different kinds of plotting as well? So in these two cases, command number 4 and 5, we have seen two different graph types. One was this, another one was this, right? Now, what if we wanted to plot two different variables at the same time? Let's say we want to plot two different numerical variables at the same time. So once I will be giving iris dollar. That's one of the numerical variables I'm choosing as sepal length. And for the specifying the second variable, we have to give a comma, then again mention the data set, give the assignment operator, and choose any other one of the variables. So since we'd already chosen sepal length, I will be choosing any one of this 4. But let's say I wanted to plot only two numerical variables. So let's say I'm choosing sepal width. So these two now, if we wanted to plot together, we're going to get a scatter plot of sepal width in the y-axis and sepal length on the x-axis. This was a combined plot for two different variables contained in the same dataset. Now, taking this same example, what if we wanted to plot a numerical data with a categorical data of the same dataset? So we're choosing iris. I'm assigning one of the first numeric variables as sepal length, and then say I want to add a categorical variable. And as for categorical variable in the dataset iris, we only have one option, which is species. So now if I wanted to plot this particular command or one numerical variable with one categorical variable. So this is the kind of plot that we are getting. But already seen previously that all of the three sub-variables, those are versicolor and virginica, which were contained in the species variable of iris, all of them had the same frequency. So see, there is no particular change in how the scatter plots are mentioned here. They're all coming in a straight line based on their particular values of sepal length. So this is the kind of plot that we're going to get whenever we're trying to plot a categorical and a numerical value together. So let's say now I'm trying to customize our plots. So let us start with customizations. Customizations of plot. So let's say I'm choosing any one of these. Let's say I'm trying to plot the sepal length and sepal width together. Both of them were numerical variables. So if I plot them initially together, they are supposed to give me a scatter plot like this. Now, what if I am not satisfied with how this graph looks? So what I can change some of the visualizations here so that the graph looks more neat or more up to my taste or more how I am wanting the graph to look. So let's say one of the first things in customizations which we can change is color. All of these graph on the plots here are black and white. So let's say I want to change the color. That is, I am trying to change the color. Now, how many different kinds of colors are already predefined in R? If you want to check that, we can simply tap here. And instead of providing any particular color between the brackets, we simply run this particular line. That is colors, blank brackets. So if we run this line, we're going to get in our output or console window all of the different types of colors present in RStudio. So we can see we are going to get a huge variety of colors that we can choose from this 657 rows and 4 different columns. So there's a huge variety to choose from. So let's say I am choosing dark golden red, this particular color. Dark golden red 2. One. I'm just copying it for my reference. So now instead of doing it here, what I will do is in this particular line, plot iris sepal length, iris sepal width, the line on executing which we gave this particular plot. In this particular line only, I will be giving a comma and I will be simply writing color equal to, now in double quotes, I'm going to write the name of that particular column, which I have already copied from here. So it's dark goldenrod 2. So now what it is saying plot iris sepal length, iris sepal width. That is two of the variables of the same data set are going to get plotted against each other. But now one of the customizations I'm adding is color dark goldenrod 2. So if I execute this command now, we can see our graph, all of the scatter plots here are now changed from black to goldenrod 2. Similarly, we can choose any other color. Let's say violet red 2. I'm selecting it from here. And instead of dark goldenrod here, I'm now simply changing it to violet red 2. And if I want to execute, check the plot command. See, the goldenrod 2 changes to violet red 2. So when I am not giving any color specifically, it always comes in black and white. Whenever I want to change the color of the plots, I can choose any color that is present here and write it as color equal to within brackets the name of the color. Now instead of writing the name of the colors, we can sometimes also give the codes all single colors, all of the colors present here have their different codes. Now, remembering the codes can be a little bit different. So what you can do is we can simply use the help command to know about a color, a particular color, which we are going to get here. There we are going to get one particular code. So let's say I remember the code for red. It was hash CC 40s. Right. This was the code for red. So I can simply write red here, or I can write the code for the particular color as well. So if I do it and change it, see, now my plot has been changed to a distinct red color. This is neither golden red 2, this is neither violet red 2. This is pure red. So instead of writing the color here, if I want to, I can also denote it by its code. But obviously, for most people, remembering the code is not practical. So you can simply copy paste the color from here. Let's say purple 3. So why do I need to remember the code? I can simply take the color from here and copy it here. And once I execute it, see, the color of my plot is again changing. So this is the first step in which we can customize the color of the plots. But the customization does not end here. And it is not necessary that for a new customization, we need to write one more command. How many customizations we need in whatever manner, we can write it in the same line here. So in the first part, we had only added this much, color equal to the desired color as our customization. Now we are going to add one more customization variable, which is called PCH. PCH stands for point character. And on point character, we're going to change what kind of shape these particular scatter plots are going to appear in. So let's say on PCH, I am giving one particular value, 19. Now this value determines what kind of shape these particular scatter plots will arrive in. At this moment, you can see I have not yet executed that particular line. So this was on the previous one. So as we can see, the scatter plots are still coming in circles. They are coming in open circles of the color violet red or violet, whatever we chose in the last place. Let me change it to red only for our betterment. And we are not yet activating point character. Right. So we changed it to red. Now what we want to do is change these particular shapes. Instead of giving them a circular blank shape, let's say I want to change their shape to something else. So what I'm going to do is I'm writing PCH, that is point character, and I am specifying a particular number. Now based on this number, the shape of this will change. So see, as I now execute this particular line, see the shapes of the scatter plots have been now changed to solid circles. So previously what we had seen were circles which had a blank space between them. They were just circles, blank circles. Only the marginal color was changing. Here what we're seeing is when we're changing the point character, the entire shape of the plots are changing. We have changed it from a single normal circle to a solid circle. Since the color was already predetermined as red, the entire circle is now a solid red circle. But it does not end here. We can change the number to anything we want. Let's say we're changing from 19 to 9. So whenever we're doing that, see, now the solid red circle has been changed to a diamond shape or rhombus shaped position. Similarly, we can change from 9 to, let's say, 45. Now see, the rhombus has been changed to single dots or very small hyphen like. We can even change them to alphabets and any kind of special characters we want. So see on 90, we are getting all of the scatter plots as Z. So similarly, we can go for all the consonants, all the alphabets, all the numbers. Even on consonants, we're going to get on the capital letters and the small letters. And based on that, there will be different point characters, the value which we're going to change every time here. So based on our point character, let me revert back to 19, which was our solid circles. So based on our point character, the shape of the graph or the plots is going to change. So what are the customizations that we have done till now? We had started with color, where we changed the color of the plots, the color of the scatter plots, which were present in this particular graph. Then what we did was to change the shape of the particular graphs however we wanted to. But here also again, the customization does not stop. Let's say we want to further change something. Since this is a graph, if you look carefully, there should be something on the x-axis, right? And it is already showing whatever we gave it on default. That is iris sepal length data. That is the sepal length variable of the iris dataset has been plotted in the x-axis. And the iris dollar sepal width, that is the sepal width variable of the iris dataset has been plotted on the y-axis. But let's say if I want to change these values, because even though I know what does this mean, many people who are seeing this graph for the first time, may they do not have any idea about what these are going to be. So let's see if I want to change these values. So what can I try to do? I can simply use one more customization feature, which is called xlab, or as it stands, x label. So what we're doing, we're basically changing the label of the x-axis that is present in our graph. So when we were not giving it was anything, it was all by default capturing whatever the data and the variable it was trying to plot. But now say I want to write xlab as, instead of iris dollar sepal dot length, let's say I'm writing sepal length. So it's much better. Instead of this dollar and dot signs, this was the generic sign. Instead of that, I'm writing a specific characters, which it is going to show now in the X level. So whenever I'm going to execute this program, see my iris.sepal.length, iris dollar.sepal.length now got converted to the particular value that I wanted to put here. Now instead of sepal length, if I wanted to put sepal L as for a short term and execute it, see it is now getting changed to sepal L. Let's say I'm diverting back to sepal length only. But at this particular point, please note that only on the x-axis we have the label change. The y-axis is still as it was before, iris.sepal_length.width. But however, here what we're trying to do is change the y label as well, not only the x label. But in the customization, we had only used x label. So now we are going to change the y label as well. So for that, the command is very same. We're going to do a y lab. Just like the previous one, which was X lab, this one is Y lab. So in Y lab, we are now going to do, since we are plotting sepal width, so instead of iris dollar sepal dot width, let's say we are only going to write sepal width. And now if I want to execute this program, see, from the entire graph, the x-axis level and the y-axis level have both been changed. So this is how we can change the labels on the axes. But even then, this graph, we are missing something. What are we missing? We're missing a title of the graph. Let's say we're trying to plot a graph. We're giving the values for the x-axis and the y-axis, and we're also giving the labels, but we're still missing the main title of the graph. So to provide a title to this graph, we want to customize it even further. And to do that, we're using the customization feature called main. Main means whatever we're going to type inside double brackets inside the main, that is going to appear as a title of the graph. So let's say I want to give the graph as sepal length versus sepal width, because those are the two variables that we are choosing. So let's say I'm writing sepal sepal length versus sepal width. Now, if I run this entire command together, see, we have our customized graph, we have changed the color, we have changed the shape of the plots, we have changed the labels on both of the axes, and we now also have a title of the graph. So this is how we can customize a graph based on our own needs. Now, obviously, the customization does not end here. We can do many different types of customizations even further from this part, but this was to give you a generic idea about how customizations can be done on basic graphs and basic plots. So let me clear this one here. We use Control L here as well, and let's deleting this particular plot as well. Now these were all of the graphs that we had plotted using the basic generic commands or the basic data sets. What if we want to plot a mathematical or a statistical graph using formulas? So we can do the same thing here. As our base package is already activated, I do not need to write library datasets again to write a plot. And instead of mentioning a dataset or loading a dataset in our global environment, we can directly use the mathematical commands to plot one particular curve or mathematical function. So let's say I want to plot the cosine graph. So how we can do that? We can simply use the plot function. Now what do we want to plot? A cosine graph. So we write cos here, that is the cosine graph that we want to plot. Now we also need to provide the limits of the graph, the cosine graph. It is starting from one point and is going to end at another point, right? So we also need to provide the limits of the graph. So let's say I'm mentioning it is a cosine graph, and let's say I am giving the starting point as 0. So the cosine curve will start at 0 and it will go all the way up to 2 pi. So whenever we are writing pi like this here, R recognizes that it is the pi value. So what does this particular line mention here is that we are trying to plot a curve, a cosine curve, which is starting at 0 and which is ending at 2 pi. That is, we are providing the limits as well. So now if I want to plot this particular curve, see, we're getting a cosine curve, which is just like a reverse sine curve. It is starting from we're giving the limits. It is starting from 0 and it is going all the way to 2 pi. So the curve variation will go like this. And even though we did not provide any customization, see, it has already plotted it as a cos curve, cos line, and it is start plotted with respect to the x-axis. Similarly, we can plot different other mathematical curves as well. So let's say now I want to plot an exponential curve. So I'm going to give plot. We use exp to show that we are trying to plot an exponential curve. Once again, we have to provide the limits of how much the exponential curve we want to start and end it from. So let's say I'm giving from 1 to 5. This signifies that the exponential curve starting from 1 and ending at 5. So if I want to plot this particular curve, see, we're getting the basic exponential curve and how it starts almost at 0, but it never actually touches 0, and it goes all the way up to the desired value. And since we had plotted only up to 5, so it is coming up to 5 only. See, on the x-axis we plotted it, it started from 1. The value is also present here, right? How does an exponential curve flatten out? It goes very near to 0, but it never touches actually 0. And it is going all the way up, and it is continuing infinitely. However, we have given for our own various purpose, we have bounded that particular exponential curve from 1 to 5. So that's what it is showing in this particular curve. Similarly, if we want to plot a denorm curve or a density normal distribution curve, what we can do is we do a plot we use the term T-norm, that is used to show a density normal curve in RStudio, and we define its limits. So let's say we're starting from -3 and we're going all the way to +3. So if I want to plot a curve here, we simply execute this and see we're going to get a normal distribution curve. As we know, the shape is very similar. It looks like a bell-shaped curve as the normal distribution curve says. And see on the x-axis, it is starting from -3. It is going all the way to +3. We know the curve also exists beyond this point and beyond this point as well. However, since we had already bounded the curve to -3 to +3, that is why the curve is only showing up from this particular point, going all the way to the top, and then again coming down to this particular point. So this is an example of plotting a density normal distribution curve in RStudio using the formula. Similarly, we can plot sinusoidal curve, we can plot all different types of mathematical and statistical functional curves using different kinds of formulas and setting their limits. However, we were talking about customization, right? So the curve does not need to be bland like this. I mean, this is a pretty self-explanatory curve. It's starting from here and it's going all the way up, down, and top. It looks like a normal well-shaped curve, but it is only a black and white curve since we're not customized anything. But now, what if we want to change the shape and color of the curve? Previously, we had seen when we were using the iris dataset, what we did was change the color of the scatter plots and change the shape as well. But here it is a curve, right? So it is going to be a line. This is not a straight line, obviously. So what we can do when we are going to customize is we can change the X level, Y level, and the table of the graph as well. However, we are going to change the color of the curve as well, right? So to do that, we're going to customize our density normal distribution curve. So let's say I want to change the color of the curve at first. So what I'm going to do, just give this the same thing, color. Now color equal to, I'm going to give, let's say, red. I could have also given the code for the color red, but using the name of the color is much easier to do so and much easier to remember as well. So if I simply execute it here, see, the rest of the curve is remaining the same. Just the curve color itself has been now changed from black to red because we specifically mentioned that the color of the curve is now going to change from nothing to red. When we were giving nothing, the color was default by black and now it is red. So we have changed the shape, not yet the shape, but the color of the curve. Now if I want to change the shape, now in the previous scatter plot, we had changed the shape of the plots that were present in, like the small circles were changed to solid circles, then we changed it to rhombus, then the lines, then the alphabets. But here it is a curve, right? It's a line. So we cannot basically change a line into any alphabet or so. So what we can do is we can change the width of the curve. We can change the thickness or the entire line width into different positions. So let's say I'm using one more customization feature called LWD. LWD stands for line width. So here also we're going to give a value just like we used in PCH or point character. So if I'm going to give a value here, let's say 2, and if I execute this particular command, see, if you check our graph's line width has increased. Previously it was nothing or it was 1 by default. So now I am changing it to 2 or it is twice as thicker as it was before. Similarly, if I change the line width to even further, if I change it to let's say 4, it will be even more thicker. The higher the value of the line width that I give, the thicker the curve will be. But let's say I do not want to stop here either. What we can do else, we can also change the labels of the curves right here, here, and we can also add a main title of the plot. So let's say I want to change it to This is a curve for normal distribution, right? So let's say I'm changing it to normal distribution. However, we're not only stopping here, we're also wanting to change the x level and the y level. So let's say I'm changing the x level to z scores. That is the values that we're going to get on the x level. And similarly, I am changing the y level to density. So now if I plot this particular graph, we can see that we have a completely customized normal distribution curve, which is still between -3 to +3 because we did not change the initial limits. However, what we did change was to change the color of the curve, change the thickness of the curve, give a title to this particular plot, and change the levels of the curve as well. So this is how we can customize a plot which can be used using a formula, not just on datasets. So we can use all different techniques for customization. There are many different other parameters which we can also use for customizing graphs, but this gives a basic idea about how we can use customization to change how the graph or the plot looks. So on our next lecture, we will be continuing with the different other types of plots that we're going to have. These were all generic plots. Now we're going to get specifically on the type of plots that we want to show in R. So that's what we will be continuing on the next class.